Hello, in this screencast I will demonstrate the use of requirements languages in FAST. So let me start by a short live demo how to use this. For this I will create a solution live demo. In this solution I'm creating a model requirements live demo. Very importantly, in order to create requirement models we need to select the requirements dev kit. Once we have a model and the corresponding dev kit enabled, we can start creating requirements. I want to create a requirements document, first requirements. And here in a document, we can have a list of requirements. So 01, top level rec, created by John. It's of a certain kind. A requirement has a title and a few extensible fields here, plus specification. And the obvious specification for requirements is some textual specification, some natural language text. This is ambiguous and normal. However, we can add other kinds of specifications to the requirements. For example, we can add temporal logics. And here we have the temporal logic patterns. For example, globally, something eventually holds. What is this something? We don't have any system model to express our pattern. So we can use a text expression. Car will stop, eventually holds. In this specification fragment, we mix formal models, temporal logic patterns, and informal predicates, which represent some conditions which might or might not hold. If you want to add a sub-requirement, you can do this. So pressing enter in sub-requirements, 0101, sub. This is created by Bob, and we can further add text. So here, if I'm clicking, then the entire requirement 01, including its sub-requirements, are shown, are selected. Let's have a look at several examples of requirements which are defined currently in the safety tutorial. We have here several examples with increasing formalization and modeling. So our goal is to enable a smooth transition between pure natural language text and models. You might notice here that inside of requirement text, we can integrate also pictures. Very useful, for example, if you have picture of that and you want to use it. So here I say, okay, 10% scale is too low, so let's use 40%. The second example here contains boilerplates as text, as I've presented before. Another example is about temporal logic specifications for requirements. So here, suppose that you have a system model, in this case, an airbag system, which is defined as an SMB module. So in this SMB module scope, we have different temporal logic specifications, pattern specifications. So here we say that, okay, at some point, eventually some collision will be detected, and after the collision is detected, it is always the case that the airbag explodes. We have a second set of requirements about the activation of the airbag. What is the problem with these requirements? Well, these requirements suppose that you have here several tens or hundreds of such sentences. Might be that they are inconsistent. So they might be not realizable. And we can check that. We can check requirements consistency using USMV. And these requirements are not consistent, and they are not consistent due to the fact that in the first requirement, we say that after collision is detected, it is always the case that airbag explodes. However, in the second one, we say, okay, if the airbag is deactivated, then the airbag will not explode. So basically, this brings a consistency problem. If I'm deleting this requirement here, for example, and check it again, the requirements are now consistent. In the same manner, we can write requirements and bring here entire model parts as specifications. So let's see, not here, let's go in the other one, the other example here, and I can say, look, please bring me the SMV module, which is already defined, and I can select one, and this module is now projected here as part of the specification for this requirement. Last but not least, we can trace other models and use those traces as specification. So let's say to this one, that requirements trace was 04001. Okay, 040. I have two requirements with the same name here in this time. And here we can bring any traced node as part of the requirement specification. So the tracing is bidirectional. The airbag is traced. You can see in this manner you create a proximity between models and textual requirements. And you can choose to collapse or expand this in order to look at the details of your specification. Thank you for watching this.